Namaste, Jai Hind, and welcome to Bharat Leads. If I asked you to picture a scientist from history, who pops in your head? Probably Newton getting hit by an apple, or Galileo looking through a telescope, or Einstein writing on a chalkboard or something. We are conditioned to believe that science is a Western invention, something that happened in Europe after the Renaissance. We are taught that while the West was inventing calculus and steam engines, the East was just sitting around being spiritual. But that narrative is not just incomplete, it is factually wrong. While Europe was struggling through the Dark Ages, fighting plagues and burning witches, India was performing cataract surgeries. While the Romans were struggling to count past 1,000 using clumsy letters, Indian mathematicians were calculating the distance to the sun. Historian Will Durant once said, India was the mother of our race and mother, through the Arabs, of much of our mathematics and surgery. But somewhere along the line, history was rewritten. The colonial narrative needed to portray India as primitive to justify ruling it. They couldn't admit that the primitive people they were ruling were actually the ones who taught them how to count. Today on Bharat Leads, we are taking back that narrative. We are going to look at the engineering, the chemistry, and the medical genius of ancient India. We aren't just listing inventions, we are uncovering the true history of how the modern world was built. From the code that runs your computer to the steel in your skyscrapers, this is the true story of Indian science. Let's start with the foundation of all STEM fields, mathematics. Have you ever tried to do multiplication with Roman numerals? Try multiplying 14 by 97. You can't do it easily. Roman numerals were good for recording things that already existed, like counting soldiers. But they were useless for complex, abstract calculations. The world needed a placeholder, a way to say there is nothing in this column, but the column still exists. In the 5th century, a genius named Aryabhatta worked in Kusamapura, which is modern-day Patna. He explicitly stated, Sthanam Dasha Gunam, meaning from place to place, each is 10 times the preceding. This is the birth of the decimal place value system. But the real game changer came slightly later with Brahmagupta in the 7th century. He was the first to define zero or shunya, not just as a placeholder, but as a number itself. He gave rules. A number minus itself is zero. 0 divided by any number is 0. This sounds simple to us, but at the time, it was revolutionary. In Europe, the concept of zero or the void was considered heretical by the church. How can nothing be something? It was considered the work of the devil. It wasn't until the 12th century when the Italian mathematician Fibonacci traveled to North Africa that he found Arab traders using this incredible Hindu art of 9 method. He realized, wait, this makes calculation much faster. He brought it back to Europe, and essentially India taught the West how to do math. Why does this matter today? Because of binary, 1 and 0. on and off. Without the philosophical leap to accept shunya, the void as a valid mathematical concept, there is no binary code, there is no software, there is no Google. The entire digital age rests on the shoulders of Indian rishis who were meditating on nothingness 1500 years ago. Now I want to tell you a story. A specific story that happened in 1793 that shocked the British Empire. There was a man named Kawasji, a bullock cart driver who worked for the British Army. During the Anglo-Mysore Wars, he was captured by the Sultan's forces. As a punishment, his nose and one of his hands were cut off. Kawasji returned in disgrace, but a year later, he was seen with a new nose. Not a wooden nose, not a wax nose, a nose made of living skin. Two British surgeons, Thomas Crusoe and James Findlay, were stunned. They asked him who did this. Kawasji led them not to a fancy hospital, but to a potter's brick house in Pune. There, a traditional Vaidya, or a physician, performed the surgery using a technique from the 2500-year-old text, the Sushrut Samhita. This technique involved cutting a flap of skin from the forehead, twisting it so the blood supply stay connected, and stitching it over the nose area. Sushrut, the father of surgery, wrote this text in 600 BCE. He didn't just guess, he practiced. He taught his students how to make incisions by having them practice on gourds and watermelons. He taught them how to stitch by practicing on leather and cloth. When the British saw this in 1793, they rushed to publish it in the Gentleman's Magazine of London in 1794. This publication is what birthed the modern plastic surgery. Joseph Carpue, the father of Western plastic surgery, actually performed his first rhinoplasty 20 years later using the Indian method. So the next time you hear about a celebrity getting a nose job, remember, that's not Hollywood magic. That's ancient Indian engineering. If you visit Delhi today, you will see a massive iron pillar standing in Qutub Minar complex. It has been there for over 1600 years. It rains in Delhi, it gets humid, it is one of the most polluted cities on earth. Any modern iron left outside would be a pile of rust within a few decades. Yet, this pillar looks almost new. For centuries, this was considered a mystery, even magic. But it wasn't magic. It was Wootz steel. Indian metallurgists were the masters of the ancient world. While Europe was struggling to heat furnaces hot enough to melt iron properly, Indians in the south, like in Tamil Nadu and Telangana, were using crucible technology. They would put iron and carbon into clay pots, seal them, and blast them with air. This increased the pressure and heat, creating a high carbon steel that was incredibly superplastic. This steel was exported to the Arab world, where it was forged into the legendary Damascus swords. These swords could slice through a falling silk scarf or shatter a European knight's sword without chipping. Here is a fun fact. Michael Faraday, the legendary scientist who gave us electricity, spent years in the 19th century trying to reverse engineer Wootz steel. He failed. He couldn't figure out how the Indians did it. It wasn't until 2006, yes, 2006, that researchers using electron microscopes found carbon nanotubes in ancient Wootz steel samples. Ancient Indian blacksmiths were unknowingly using nanotechnology 2000 years ago. That is the level of sophistication we are talking about. Let's talk about chemistry. Specifically, the mystery of zinc. To make brass which looks like gold, you need copper and zinc, right? The Romans loved brass, but they made it by accident. They could not isolate pure zinc ever. Here is the science problem. Zinc is a nightmare metal. Most metals melt into a liquid, and then if you get them really hot, they boil into gas. Zinc melts at 419 degrees centigrade, but it boils at 907 degrees centigrade. In a standard furnace, by the time you extract the metal from the ore, the temperature is already over 1000 degrees centigrade. The zinc doesn't melt, it vaporizes. It turns into smoke and flies away. For centuries, alchemists described zinc as a strange metal that disappears. Except in Rajasthan. At the Zawar mines near Udaipur, Indian chemists cracked the code in the 12th century. They invented the world's first downward distillation process. Imagine a clay pot, filled with ore, flipped upside down. They applied heat to the top of the pot. The zinc would vaporize and travel down a tube into a cool chamber below and condense back into a liquid before it could escape. This wasn't a small experiment. We have found millions of tons of clay debris at Zawar. This was the world's first industrial-scale metal factory. This was a huge monopoly for India. India supplied the zinc for the whole world. So what happened? Industrial espionage. In 1738, a British metallurgist named William Champion traveled to Rajasthan to study the process. He returned to Britain and patented the exact same process, calling it his own invention. The British zinc industry was built on stolen Indian intellectual property. It is a classic example of how the history of science is often written by the victors, not the inventors. Finally, we have to talk about fabric of our lives, cotton. The ancient Greeks didn't have a word for cotton. When Herodotus, the Greek historian, wrote about India, he said, "There are trees growing wild which produce a kind of wool better than sheep's wool." They were baffled by it. For 2000 years, India clothed the world. We domesticated cotton. We invented the dyes, indigo and others, and we invented the machines to process it. The most famous example was the Dhaka muslin. It was said to be so fine that a 6-yard sari could pass through a wedding ring. It was called woven air. Roman emperors complained that their treasury was being emptied to buy Indian textiles. But this innovation became India's curse. When the British colonized India, they didn't just want to buy the cloth, they wanted to own the market. They systematically destroyed the Indian textile looms, imposed heavy taxes, and took the raw technology. The roller gin improved it slightly with steam and started the Industrial Revolution in Manchester. The Industrial Revolution, which we are told started in England, was fueled by Indian raw materials and Indian technical know-how. The Indian charkha wasn't just a symbol of protest. It was a reminder of a time when India held the technological supremacy of the world. So, why does this matter? Why talk about zinc furnaces and old manuscripts? Zero, plastic surgery, rust-free steel, zinc distillation, cotton textiles. These weren't just accidental discoveries. They were the result of a culture that valued jigyasa, or curiosity. A culture that saw science and spirituality not as enemies but as two sides of the same coin. The purpose of knowing this history isn't just to feel proud, though we should be. It is to realize that innovation is in our DNA. The same soil that produced Sushruth and Aryabhatta is now producing the minds behind the UPI payment system, the Chandrayaan moon mission, and global tech leaders. For the last 200 years, the confidence of the Indian mind was broken. We were told we were a nation of snake charmers and mystics. We forgot that we were a nation of metallurgists, surgeons, and mathematicians. Science is not foreign to India. It is indigenous. It is native. The logical rigor of coding is in the structure of Sanskrit. The curiosity of space exploration is in the verses of Aryabhatta. Today, Bharat is leading again. From landing on the south pole of the moon to building the world's largest digital payment ecosystem, we are reclaiming that legacy. The true story of Indian science isn't just about what we did. It is about who we are. And if history is any indication, the next big innovation that changes the world might just be brewing in a classroom in Pune or a lab in Bangalore right now. If you are proud of this history, hit that like button and share this video. Let's make sure the world knows the true story. Jai Hind.